Today we're going to talk about multiplying polynomials. So we're going to look at two different ways, and this is the first one, to multiply a polynomial by a monomial. So a polynomial, remember, has multiple terms that are connected with addition or subtraction, and a monomial is just a single term. If we're going to multiply a polynomial by a monomial, then we're just going to use the distributive property. And so here's our first example. Simplify x times the quantity 2x squared minus 3x. So I'm going to distribute the x to everything inside the parenthesis. So it's going to go there, and it's going to go there. And this is what it looks like when I do that. I have 2x squared times x minus 3x times x. So I've multiplied everything inside by x. And now we're going to use what we learned in the previous lesson about multiplying monomials to simplify this. So I'm going to do each term separately. So 2x squared times x. Well, remember, if there's not a number in front of the variable, it's a 1. So it'd be 2 times 1, which is 2. And if there's not an exponent with the x, then it's a 1. So I have x squared times x, so x to the 2 plus 1, or x to the third. So I get 2x to the third, and then I do the same thing with the next one. I have negative 3 times 1, which is negative 3, and x times x, well, that's x to the first times x to the first. 1 plus 1 is 2. So I have 2x to the third minus 3x squared. Our next example is similar. I'm again going to distribute that 3x squared to everything inside the parentheses, so it goes there and it goes there. So when I do that, it looks like this: x to the third times 3x squared plus 4 times 3x squared. Well, x to the third, it's 1x to the third times 3x squared, so 1 times 3 is 3, and x to the third times x squared is x to the 3 plus 2, which is 5. And then I have 4 times 3, which is 12. And there's not an x with the 4, so I just have x squared. So it's 3x to the fifth plus 12x squared. Okay, this one is similar, except it has one more term in the inside the parentheses, and it doesn't change the fact that we're still going to distribute. We're just going to distribute to one more thing. So it goes to the 5x squared, it goes to the negative 3x, and it goes to the negative 2. So when I distribute it, it looks like this. I have 5x squared times 2x to the third minus 3x times 2x to the third minus 2 times 2x to the third. Well, 5x squared times 2x to the third. 5 times 2 is 10. X squared times x to the third is x to the 2 plus 3, which is 5. And then negative 3 times 2 is negative 6. X to the first times x to the third is x to the fourth. And then negative 2 times 2 is negative 4. And it's just x to the third because the negative 2 didn't have an x term. So 10x to the fifth minus 6x to the fourth minus 4x to the third. So it's just taking exactly what we did yesterday, or in the previous lesson, and applying it here as we distribute. Now, if we're going to multiply any two polynomials together, we're going to use that box method. Now, I'm going to tell you right here that in ALEKS, if you look at examples, that's not how they're going to show you how to do it. So you're going to want to pay attention to this, and I believe that this box method is a much easier method than what they're going to show you in ALEKS. So I would keep my notes handy and make sure that I totally understand this box method. Or, I mean, you can look at examples on ALEKS, and if you like the method that they do better, then please, by all means, use that method. It doesn't matter to me. I just find that I think the box method is a little bit easier because it keeps everything organized. So here's what it looks like. I'm going to multiply x the quantity x plus 4 times the quantity x plus 6. And I've underlined them in blue and red so that you can see when I go to my box, I'm going to put the one that's underlined in blue, I'm going to put in blue, and the one that's underlined in red, I'm going to put in red, just so we can keep track of where those things came from. And I just multiply into the box. So I do x times x, and I get x squared. I do x times 4, I get 4x. I do 6 times x, I get 6x. And 6 times 4 is 24. Please use a calculator if you need to. It's perfectly fine to do that. Now, the really nice thing about this box is that the diagonals are always going to be like terms. So watch, I'm going to draw the diagonals in so you can see that. So there's one, here's my other diagonal, and here's my other one. So anything that's on the same color line gets added together. So the first thing, I just have the x squared, and so I have x squared, and then I have 6x plus 4x, well that gives me 10x, and then I just have 24. So I get x squared plus 10x plus 24. I really like this method because everything ends up, like I said, diagonals are like terms, and if you do it this way, everything turns out to be in standard form. Remember, highest exponent down to lowest exponent, and that's standard form. So we have x squared, x to the first, no x. Let's look at another one of those. I have x minus 2 times x plus 3. So I draw my 2 by 2 box. I put x minus 2 up there and x plus 3 right there. I multiply into the boxes, so x times x gives me x squared. X times negative 2 gives me negative 2x. 3 times x gives me 3x. And 3 times negative 2 gives me negative 6. I draw in my diagonals. So remember, I add everything that's the same color together. I don't have anything to add to that x squared, so that just stays x squared. Negative 2x plus 3x. Well, that gives me positive 1x, and then I have negative 6. So I end up with x squared plus x minus 6. And I can't simplify anymore because none of them are like terms, and they're already in standard form. All right, well, this is the same kind of problem except that it has a squared in there where my other ones did not have that. So I'm still going to do the same exact thing. I draw my 2 by 2 box. I put the blue ones on the top, x plus 4, and I put the red ones on the side, x squared plus 2x. And just so you know, it doesn't matter. You can put the blue on the side and the red on the top. It doesn't matter because you're just going to be multiplying anyways, and so the order wouldn't change. All right, so I start by multiplying x squared times x, and I get x to the third. I multiply x squared times 4, I get 4x squared. I multiply 2x times x, I get 2x squared, and I multiply 2x times 4, and I get 8x. I draw in my diagonals. These diagonals are also a nice way to see if you multiply the exponents correctly, because remember, anything on the diagonal should be the same like terms, same exponents. So now I'm going to just write down what I have. So on the green diagonal, I have x to the third. On the yellow diagonal, I have 4x squared plus 2x squared, which is 6x squared. And then I have 8x. So I get x to the third plus 6x squared plus 8x. And that's it. Now this last example is the quantity x plus 1 times the quantity 3x squared plus 4x minus 6. This one's different because it is a binomial. Remember, bi means it has 2 terms. And the second one is a trinomial. Trinomial means it has 3 terms. And we haven't looked at one of these. Same exact way, except instead of a 2 by 2 box, I'm going to do a 2 by 3 box. And my diagonals should still all be the same. So I'm going to put x plus 1 on the top, and I'm going to put 3x squared plus 4x, and then I'm going to put a plus negative 6, so I remember that 6 is negative. All right, now I just start multiplying things together. 3x squared times x gives me 3x to the third. 3x squared times 1 gives me 3x squared. 4x times x gives me 4x squared. 4x times 1 gives me 4x. Negative 6 times x gives me negative 6x. And negative 6 times 1 gives me negative 6. I draw in my diagonals. This time I have one more diagonal. So I don't have anything to go with the 3x to the third. There's only one number on that diagonal. I add the yellow diagonal, those numbers together. 3x squared plus 4x squared is 7x squared. And then I multiply 4x. I add 4x minus 6x. So that's negative 2x. And then I have negative 6 on the blue diagonal. So I get 3x to the third plus 7x squared minus 2x minus 6. So I think that you will find that this box method is a really nice way to keep it all organized, and it seems to be, to me, a little bit easier because everything comes out like the diagonal should be like terms. So there's a lot of checks in there to make sure that you didn't multiply something incorrectly. So I know that some of you have been taught FOIL. FOIL gets up really messy when it's anything more than a binomial times a binomial. So just be careful of that. And again, like I said, the examples on ALEKS are going to be different. They're going to do a different method, but you can feel free, if you understand that method, feel free to use that method. If you can use the box. Just make sure that you've taken some good notes on the box method so that when you get to the assignment, you have those notes to follow. So the assignment is in ALEKS for this one. Remember, you can do the assignment and you can go back and correct anything you got wrong. You can do that as many times as you want to do. You have to in order to get credit for the assignment, you have to have at least a 60%. So that would be 6 out of 10 correct. But I would shoot for more so that you have a good understanding of how to do this, because it's stuff you're going to use next year in Intermediate Algebra 2D, C, Intermediate Algebra 2C, first semester. So I would make sure that I did better than just 6 out of 10. All right, so that is the end of this lesson. Thanks for watching, and stay safe, stay healthy, and check next week for the lessons for next week. Have a great week.